Hello, I'm Ma Jianlu from Sichuan Vocational College of Chemical Technology. Today, we are going to learn about the plasticization and reinforcement of polymers. Plasticization and reinforcement of polymers typically involve improving material properties to meet specific application requirements. Plasticization is the process of lowering the glass transition temperature of a polymer and increasing its flexibility by adding plasticizers. Plasticizer molecules interact with polymer chain segments, weakening the intermolecular forces between chains. This allows the polymer chains to slide more easily, thereby improving the material's flexibility and extensibility. There are three main types of polymer plasticization: internal plasticization, external plasticization, and autoplasticization. Internal plasticization is the process of modifying the polymer chain's chemical structure, that is, copolymerization, to achieve plasticization. For example, using the flexibility of butadiene units. High-impact polystyrene can be prepared. External plasticization involves adding low molecular weight liquids or flexible polymers to a rigid polymer chain to achieve plasticization. Substances with this effect are called plasticizers. The principle is that low molecular weight substances have much lower viscosity than polymers. Therefore, for every 20% added, the system's viscosity decreases significantly. Both the glass transition temperature and the viscous flow temperature decrease. Autoplasticization refers to the phenomenon during plastics processing where plasticizers automatically modify the physical properties of the plastic, making it softer and easier to process. Plasticizers are generally small molecules. They can insert between polymer chain segments, weakening the intermolecular forces. This makes the chains move more easily, thereby increasing the plasticity of the polymer. The plasticizing effect of plasticizers generally lowers the glass transition temperature and viscous flow temperature of polymers. However, there are differences between flexible and rigid polymers. For flexible polymers, adding plasticizers increases the mobility of polymer chains, thus lowering the glass transition temperature and viscous flow temperature. The decrease in the latter is greater than the former, as shown in the figure. As the amount of plasticizer increases, the high elastic region moves to lower temperatures. The elastic modulus decreases. That is, under a certain stress and a certain time of action, the deformation increases. If the plasticizer content increases to the level shown by curve 4 in the diagram, the elastomeric state completely disappears. The system becomes a solution. For rigid polymers, as the amount of plasticizer increases, the glass transition temperature and viscous flow temperature decrease. However, when the plasticizer content is within a certain range, the interaction between plasticizer molecules and polymer groups turns rigid chains into flexible ones. At this point, the glass transition temperature decreases significantly, while the viscous flow temperature does not decrease much. This effect is called plasticizing effect. This is very useful for production. For example, the glass transition temperature of polyvinyl chloride is about 82 degrees Celsius. Pure resin can only be used as plastic. After plasticization, it has excellent elasticity at room temperature and can be used to make artificial leather and films. Plasticizers also have a certain impact on the mechanical properties of polymers. They can reduce the crystallinity of polymer molecular chains. That is, they increase the plasticity of the polymer. This results in a decrease in the polymer's hardness, modulus, softening temperature, and brittleness temperature, while elongation and flexibility increase. When plasticizers are added to polymer materials, they can lower the melt viscosity, glass transition temperature, and elastic modulus without altering their basic chemical properties. This improves their processability and increases the softness and tensile properties of the product. In general, the effect of plasticizers on the mechanical properties of polymers is significant. They can alter the intermolecular forces between polymer chains, thereby changing the mechanical properties of the polymer. However, the selection and use of plasticizers must also consider their impact on other properties of the polymer. By adding reinforcing agents or enhancers to the polymer, its strength can be improved to varying degrees. This effect is called reinforcement. Reinforced plastics have found increasing applications in fields such as building materials, mechanical parts, transportation vehicles, and electrical components. For example, to reinforce thermoplastics, synthetic fibers, glass fibers, asbestos fibers, glass microspheres, carbon fibers, etc. are typically added. The most commonly used in industry is glass fiber. The performance comparison before and after the addition is as follows. Tensile strength, bending strength, and impact strength all increase, while linear expansion coefficient, molding shrinkage, and water absorption decrease. For the reinforcement of thermosetting resins, glass cloth, cotton cloth, linen, synthetic fiber fabrics, glass fibers, etc. are generally added and molded by lamination, as shown in the table. The comparison between unsaturated polyester-based fiberglass and pure resin, metal, etc. in terms of relative density, compressive strength, flexural strength, and impact strength. In this lesson, we mainly discussed the plasticization of polymers, as well as the target materials for plasticizers. Finally, we studied the reinforcement of polymer materials. In summary, both plasticization and reinforcement aim to improve the properties of polymers to meet the application needs of different fields. That concludes the content of this lesson. Thank you for listening. See you in the next lesson.